Ladies and gentlemen, hello and welcome back once again to the briefing room. Yours truly, Eric Cavanaugh here with Rod Cope of Perforce Software. Folks, Open Logic by Perforce, I should say. Very excited about this. We always love trend pieces. We're going to talk today about 4 mega trends that are affecting the industry and talk about how you can take advantage of them. So the topic exactly is harnessing 4 mega trends in data tech with yours truly and Rod Cope. Go ahead and move the next slide. So here's a couple experts for you on the call today. Rod has been doing this stuff for 25 plus years, so he's a lot of experience in the history of enterprise software, all the way through the legacy environments, client server, into the early cloud days. And now, of course, this industrial cloud era where things are really changing rapidly. In fact, we just wrote a new paper for Perforce called The New Stack, which talks about Cassandra and Kafka and some of these new technologies, Spark, and how they're dramatically changing. These are not minor adjustments in technological capability. These are revolutionary technologies in terms of the scale and the power and what you can do. But as we were musing before the show, there's all that legacy infrastructure out there, all that technical debt, as some people refer to it, that you have to worry about, wrap things around, maybe find some way into the cloud, into the next phase. That's what we'll talk about today. So next slide. So transforming IT data infrastructure, I'll talk about that. Rod will jump in on the 4 mega trends, and you can see them right there. Microservices, containers are huge these days. Hybrid cloud that follows naturally. Data fabric, that's what I'll talk about for a moment. Streaming, what's next? Final thoughts and then questions. Don't be shy. Send your questions in at any time during the webinar. We'll queue them up for the Q&A at the end. Next slide. So transforming IT infrastructure, I saw this about a year ago. I've been laughing ever since because I think it is absolutely hysterical. It is so painfully true. Who led the digital transformation of your company? The CEO, the CTO, or COVID-19? And most people would say COVID-19. We had a guy on chief data officer for Novant Health, Carl Hightower, last year. And it was probably like May or June of last year. We did a radio show with him. And he said that because of COVID, his company knocked out 5 years of digital transformation roadmap in 5 months. 5 years. So what does that show you? It shows you that when you have to do something, you can do something. You really can do it. You know, if the train is coming down the tracks towards you, it's going to run over you. Trust me, you're going to get real good at getting those shackles off your feet so you can get out of the way and let that train go by. And that is an interesting metaphor to describe digital transformation in this modern age. Lots of companies are not moving. Lots of companies are not taking advantage of these technologies, and they're just being eclipsed. I mean, just all of a sudden, the money goes away. You know, think of Blockbuster and what happened to them and how they disrupted the market. I remember, I'm old enough to remember all of those mom and pop video movie stores. They were everywhere, and they had all kinds of small business. It was a whole cottage industry. Blockbuster came in, lowered the price, knocked them all out of business. And then what did they do? They fined people. That's what killed Blockbuster, was all those late fees. They were just killing people. And then what happened? Netflix came along and blasted them clear into the stratosphere. They're gone now. In fact, there's a great comedian, Nate Bargatze, look him up. He talks about Blockbuster and how Chuck E. Cheese wants to be Blockbuster. Like, how do we do it? We want to get out. Anyway, next slide, please. So talking about data fabric, I thought to myself, it's been a pretty long and interesting journey for data and how you persist data. If you remember, if you're old enough, the original data fabric was punch cards. You would put punch cards into the mainframes. Remember that? That's a long time ago. But then it was floppy disks. I was joking with Rod before the show here that I had a compact portable way back in 1986. It weighed about 30 pounds. And you had to use little floppy disks to start it up, to load the operating system, to load the apps or whatever it was. It was like 5 disks you had to put in a row. That's the old days. That's how we did it, right? That was the data quality, the data fabric back in the day. It was just disk, first paper, then floppy disks, then hard disks. Then, of course, a guy named Steve Jobs came along eventually and said, no more floppy disks. Just said, nope, they're gone. And that changed the industry. Remember, he's also the guy who said, no more flash. Sorry. Macromedia, Adobe, no more flash. We're not going to support it. That took years. It's still a problem. Obviously, it's still out there. But this is what happens. So fabric, when I think about data quality fabric, or just data fabric in general, we're going to do another webinar on data quality fabric soon. What are we talking about? Databases for years and years were the foundation of information systems. They still are. Databases are still the mainstay. But 15 years ago or so, you had, like realistically 10 you could choose from. I mean, there were more than that, but they weren't really production capable. So you had a handful that just took over, right? MySQL became a huge thing, obviously. And then when Oracle bought Sun, what happened? They forked MySQL into MariaDB, which is now itself a prominent open source offering. But about 15 years ago is when you saw this explosion. I did an interview actually with Dr. Michael Stonebreaker, who invented the modern Postgres database in 2005, and he was explaining to me that there was a one-size-fits-all concept that just had taken over, and the relational database was used for everything. He said, well, that doesn't make sense because there are lots of workloads that are not really optimized on a relational database, like analytics in particular. So he was pushing Vertica back then, which of course is column-oriented. It's good for analytics. It's good for compression. It's good for a lot of different things. And since then, oh my goodness, there are like 240 production caliber databases now that you can choose from. There are graph databases, object stores, all kinds of analytic databases, for example, lots and lots of things. And a data fabric is actually one step beyond that, right? So a data fabric can touch into any of those sources, right? So if you think about the innovations made by Teradata and by Netezza and by a bunch of these other guys, there was a whole bunch of them for a while in the appliance space. Well, they tackled concurrency, they tackled workloads, like workload size, all sorts of different things. But now with a data fabric, you can leverage all of those different types of models when and as needed. In fact, there are even some cool new database technologies that will ascertain what kind of query is coming their way, or what kind of transaction. Is this a transaction or is it a query? And they will actually route to the appropriate database. So there's a company, Splice Machine, that talks about that. So the point is, there's a lot of fun stuff going on. Next slide. And that's Silk, obviously. I'm sure you figured that out. So, and here's declarative data pipelines. This is some fascinating stuff that's going on right now. A lot of the energy in the data space now is focusing on the pipelines and actually getting it in there. And one of the things that happened, again, kind of talking about data fabric, is a company called Snowflake, biggest IPO in tech history, basically. And what did they do? They basically proved that data warehousing is alive and well. But what they did that was very clever is they separated compute from storage. And so all of a sudden, the cost structure changes, and you don't have to pay for everything all the time. And they also figured out something very clever, which is that a lot of times you'll get an enterprise data warehouse launched and running. And of course, in the old days, that took months and years, which now it takes days or hours, depending upon how you do it. But you'd realize that the data model wasn't quite correct. Well, 15 years ago, making a change to that data model for your enterprise data warehouse, that was not a small task. I mean, you need to take that thing offline, redo it, rejigger it, re-enter all the data. It takes weeks, if not months, to get that done. Well, that's not agile, is it? So that's what's changing as well. And we're seeing a lot of really cool stuff in the data pipeline space. But with that, let me hand it off to Rod Cope of Perforce, who can walk us through some of these mega trends, and he and I will chat at the breaks between the four big trends. So Rod, take it away.
All right, thanks, Eric. Wow, you made so many good points in there I want to comment on. I think we could talk all day. So I'll try to hold it to the mega trends. We'll see where we go.
There you go.
Okay, so as you mentioned, there's a lot going on. I mean, there's so much change that you mentioned Blockbuster. I mean, the list goes on of all the industries being disrupted and change in basically every aspect of our lives. So trying to keep up with that change and going faster and faster and meeting time to market and business agility needs. I think these trends are going to be around for a while. And there's something in common with all these that we'll touch upon as we go through and as we conclude. But we'll start with microservices. So big trend. I think you'd have to be living under a rock to not hear of it, or not want it on your resume at least, whether you're doing it or not, because it's the hotness. The idea is that you have small little pieces interacting together instead of the traditional monolith, which is one big piece. Now, I think there's pros and cons. We'll get into that too. Everybody's trying to do it. Last year, O'Reilly said about 3/4 of organizations have adopted microservices, and a lot of them are experiencing success. I think it probably depends who you talk to, how much success, because there's also some failures out there. That's a lot of moving parts to deal with. And things have slowed a little bit this year, but they're obviously out there. And you can kind of look at the numbers and the big bubbles there. Microservices kind of in the lead of monoliths, but still Eric and I mentioned talking before the show, a lot of legacy, a lot of monoliths out there. Good thing about a monolith is everybody can understand what the hell's going on. Anybody can walk up to the whiteboard and draw 3 boxes that say database, app server, web server, draw 3 arrows, and you're done. You got to get the fluffy cloud in the picture. That has to be there. But then you say, okay, now draw the microservices, and they say, well, I don't even know how many we have. I think there's 700 at the last count, and I don't even know the team's working on it. So nobody can really have everything in their head, which is a different challenge to deal with. But anyway, they're here, and they're taking off because monolith is slow to change, and we're dealing with the rapid pace of movement everywhere in technology in our lives. And it's hard to coordinate a change with a monolith when you've got to get a bunch of people involved, maybe DBAs and business people and business logic people and UI people all in lockstep to figure out something together. And you make a change 6 months to get the new button on the screen versus microservice, it's an hour. So we've kind of, I think, as an industry, agreed to suck up the pain of microservices, shift the problem elsewhere, because we've got to go faster. So the benefits are, because all these features, domains, however you want to think of it, depending on if you're truly doing microservices or more like mini services or something else, you can make progress in smaller chunks with smaller teams using different technologies and different stacks, deploying more frequently. So you get, in theory, more scale, because you can scale up just the pieces of the architecture you need. If you're getting a bunch of load in one area, one microservice, scale that up. You don't have to scale everything else, so it can be more cost effective. You can get better resilience if you plan from the front to do this right from the beginning, realizing that with all these moving parts, you are doing true distributed computing. Things fail. There's all the standard fallacies of network and distributed computing to deal with. If you engineer for that up front, you can get a really good, robust system where if something goes down, only one feature is down, the rest of the site is still up and running, or the rest of the app is up and running. So small teams working on small stuff, going faster. Better control over technology. You're not locked in often for a decade plus because, we can't move from Java to Node, or experiment with Go or Python because we'd have to port the entire monolith. Instead, there's a new microservice we need. Let's try the new tech stack and see how that works. So you can be more flexible and even rewrite a microservice if you need to, because you haven't invested that much in one chunk. Now, I think what gets really interesting about data here, the topic for the day, is if you look at the little blue database boxes on the bottom, you can see that if done right, I'll put an asterisk on that a lot because not everybody does this right. The data stores are independent. There's no sharing across the microservices. Every one of them has its own independent data store. That way you don't have to coordinate change. That's the real key. If you start to coordinate, we need to do a schema migration that affects 2 other microservices that share the same database. Wait, now you're just doing a mini monolith. Now you're in lockstep, things go slower. You don't get the benefits of microservices. So done right, every microservice can pick and choose the best tool for the job. I need a relational database. I need graph. I need a key value store. I need column oriented. I need a cloud service. I need a different cloud service. I need a flat file. Everybody can pick what fits best for them. Now, of course, what you wind up with is a hodgepodge of every known technology to man. And then you try to move somebody from one team to another and they have to relearn the entire stack, but different story. So this is why we want to move there. So lots of tech to enable this kind of behind the scenes, lots of Docker and Kubernetes. If you think about shrinking from a monolithic software app down to a microservice, we've kind of done the same thing with going from a physical box to a virtual machine to now a container image to even serverless, that we keep getting smaller and smaller on the execution side as well to match. And so a lot of these technologies, you'll see Istio in the bottom left and Linkerd in the middle, kind of being these service meshes, built to handle the networking and deployment and A/B testing and canary and failover and discovery, encryption, all these kind of infrastructure services for your microservices. So you don't have to reinvent the wheel every time you build a new microservice. I think these kind of things are really important to get the benefits of moving to this new technology and new
And
architecture.
you made a one really good point there, Rod. I'd like to drill in on a bit, which is that if you embrace this microservices approach with your new applications, for example, you may have it where there's some small failure in the app where some feature doesn't work, but the rest of the app still works, right? I
Yep.
think back to, again, I'm going to show my age here, way back when, kids, when you had Christmas lights around the Christmas tree, they just had one wire going through. And so if one light went out, it would break the circuit and you wouldn't even know which light it was. You'd have to like change the first light. Nope. The second light. Nope. Third light. Nope. Fourth light. Nope. All the way around. Then someone figured out, hey, if we have another wire going through, we can complete the circuit that way. And then you won't have to figure out which of the 850 lights on your string is broken. I mean, that's how bad it was when we were kids. Like, that's a pretty deep IT problem if you think about it at the time. And they solved it with just another wire going around, like, oh, look at that, now we can fix it. So what Rod's talking about is, if you use this microservices architecture, you launch your app, well, it may be part of it, maybe some feature doesn't load because there's some problem somewhere, but the rest of the app still works instead of the whole app just crashing, which is the old way. Well, that's a huge difference. And you actually see this in even major applications you use right now. You just have to kind of look for it with Google and Yahoo and some of these guys. If you just watch, you'll notice once in a while some menu item doesn't show up, and that's what's happening. There's a problem in that little bitty part, but it doesn't bring down the whole ship, right, Ron?
Absolutely. And I am going to blatantly, shamelessly steal that awesome analogy with the Christmas lights.
It's a good one, right?
It is a really good one. Yeah, I think you'll see, as you mentioned, companies like Facebook and others are really into that. So occasionally you'll click a button and say, this failed. It's not available right now. But you can go click any other button of the 700 buttons in the app. It still works.
That's right.
So if you plan for that and you engineer for it and do it right, you can get some great advantages of that architecture where you can deploy new versions of just one feature. You don't even have to touch the rest of the app. So zero downtime.
Yeah, that's right. And there's a quick question from an audience member here who just asked, how do we ensure that we do not create silos of data with the microservices environment? If you could share some best practice on that, that would be great. And keep in mind that data is one thing microservices don't really do, at least the last time I checked. It's functionality, and they have to be attached to persistent storage somewhere, right, Ron?
Yeah, so usually every one of your microservices has its own persistence mechanism, its own data store. So, question about how do you avoid silos? It's actually siloed by definition. So it's more like the challenge is, how do you deal with the silos that you will absolutely have? If you think about individual microservices communicating with each other via API, via service mesh, via message queue, kind of decoupled, and we'll talk about more about that as we go through the slides as well. They really are independent and decoupled. So you absolutely have silos. Now it's like, okay, how do we deal with them? And that's where things like data streaming, data fabric, as we talk more, I think will come into play a little bit. Okay, any more questions at this point, or should I keep on?
No, go ahead.
Again? Okay.
Plow forward.
Right. Okay, so hybrid cloud. Another example of moving to, I think, monolithic to smaller pieces, and there's a theme throughout this whole talk. So hybrid cloud, if you don't know about it, you may hear cloud bursting, there's other terms for it. The idea that you have a private cloud internally, typically in your data center or multiple data centers, and you use at least one public cloud as well. And typically this is a way to deploy a single application. So, and it can go both directions or either direction depending on your application. So as an example, you might have a highly used app by your business that is private. It's in your own data center. It's in your private cloud because you use it all the time. So cloud is expensive. Don't let anybody tell you different. You're paying for flexibility. If you have a data center at scale, you can save a lot of money if you're fully utilizing it. That's what most people don't do. But if you're fully utilizing some app, then you need more capacity. You can say, well, let me, on the fly, elastically, automatically go borrow public cloud resources and scale out just for the need. Maybe it's end of quarter reporting, it's Christmas, and we're an e-commerce shop. I'll go scale, blast up a bunch of servers on the public cloud, have my architecture be able to handle that seamlessly. When the load dies, I shut down the public cloud. I stopped paying for it. Now I'm chugging along in standard state again in my private cloud. So obviously a lot of benefits there, a lot of work. I mean, you can't snap your fingers and make this happen if you don't architect for it up front. But a lot of organizations you can see are trying to get there. There's a lot of benefits to be had. A third of enterprises planning to get there in the next 2 years, and the businesses that have already done it are more efficient. They're deploying faster, they're moving faster. Because if you think about the olden days, I feel like we're both the old guys, Eric, just talking about, oh, in the olden days, you bought physical hardware and you had to deploy it, and you had to wait 9 months for IT to get it up and running in the data center. I can't wait 9 months. I might wait 9 minutes, but I'll be frustrated then.
Right.
Now that you can just click a button and have it in the cloud. So being more flexible about where you can deploy, where you can run, I think, again, an analogy there to monolith, going to mini services, going to microservices. This is giving us more options, more flexibility, and again, more moving parts to track and manage in an app that's spread across now potentially multiple kinds of clouds, not just multiple clouds. So why is this happening? Technical flexibility, deploy where I want, use maybe cloud services that are available on one particular cloud, but not another that I don't have access to privately. So I'm getting more functionality access, and I get business agility. Let's put the load where it needs to be for the best results, and then be able to move it around over time, which I think is also pretty powerful. So some benefits, basically, if you think of it from a pretty selfish point of view, and it makes sense, I can give the work to somebody else. In some cases, hey, put it on the cloud, let them deal with the infrastructure. I want to click a button, scale up 1,000 servers, click a button and turn them off. I don't want to mess with any of that. It's convenient. Let somebody else handle security and all the other aspects. So more elastic, more scalable. I can reduce complexity sometimes. Again, I can move load where I need it. If I need something simple, I need a serverless function, I'll use that. I need a Docker image, a container, I use that. I need a full VM, I'll use that. I need physical hardware, I'll put it in my data center. So I bite off just the amount of complexity I need. I'm not forced to have maximum complexity everywhere just to get to flexibility. I can get better availability. One cloud goes down, it's okay. I'm in multiple clouds. Improve security, I've got a question mark there. Some people think they're more secure. Usually they aren't. Usually the public clouds are more secure because they bought up all the expertise in the world essentially to make it more secure, and they can afford more than most companies can. So they probably do that right. And storage options, back again to storage. If I'm using AWS and Google and Azure and my private cloud, think of how many more options I have. You mentioned 240 plus options out there. This is a good way to leverage more of them. Oh, there's a storage option in one of the clouds the other ones don't have. That's great for this app, and that's where it gets deployed. So flexibility is king. If you look at the Gardner Magic Quadrant kind of behind this, in the top right, no surprise to see Amazon, Microsoft, and Google there. There's also tons and tons. I mean, this is a small snippet on the right of the open source projects involved in cloud. There's hundreds of them, Cloud Native Computing Foundation, things that might be even new to a lot of people. In the top left there, some graduates, new key value stores with different capabilities when it comes to ACID transactions and flexibility of NoSQL and eventual consistency versus hard consistency, things like that. Vitesse, a way to horizontally scale MySQL across clusters with connection pooling and shared caching and all kinds of cool stuff there. And that's just the tip of the iceberg. It seems like there's a new one every day. So there's no limit. It's almost, I've been saying this for a very long time, but it's tyranny of choice. There's too many freaking options now. Which one do I pick? Which one's going to be around 10 years from now? So it's every niche you would have, every use case, like, oh, I want to store it like this, but not quite the way that tool does it. Let me find something else. There's probably 15 to choose from. So you can now tune that microservice or your place in the cloud to just the kind of storage you need for just that part of one app. It's pretty powerful when you think of it. Now we don't just have, the toolbox isn't a hammer and a screwdriver. It's the 72,000 piece socket driver kit, right? You can fit anything. It's a lot.
Yeah, I like that tyranny of choice. Kind of don't like it, but it's a great way to describe it because you're right. I mean, it's like, if you only have three choices, okay, you just review three different options and make your decision. But now, I mean, that's like the blessing and the curse of the modern stack is that even though you do have these three major players under the covers, there are all of these different component parts and they're all designed for specific reasons. One of the analysts in our space gave me this great explanation a couple of years ago now. We were talking about Amazon, and when you go into the back end of Amazon Web Services, if you're a client, it's almost like the Home Depot of functionality. You walk in, you're like, oh, like there's aisles and aisles of things, and what is all this stuff? And he said the reason for that is because Amazon focuses so intently on working very closely with their clients to do what their clients need done. So you wind up with these bespoke solutions that leverage a host of services that are provided, but the sort of granular options and or even the coarse ones, right? Let's bring in the language from service-oriented architecture. You had fine-grained services and coarse-grained services. Remember that? And the coarse-grained, that's kind of what you see when you go into Amazon is all these coarse-grained services just linked as options for you. But if you go a layer beneath that, all the services, that's what you can weave together to do really whatever you want, right?
Absolutely. Yeah, it's just, there's so many options. It used to be, like I said, blessing and a curse. It used to be, okay, we're going to create a new app. All right, so here's how we're going to create the schema to work in our relational database. Because that was it. That was the decision was already made. There's no options. It's work with the DBA and figure out the schema.
Right.
Forget that your object oriented view of the world has an impedance mismatch and won't fit in those little square tables very well. We'll figure that out.
Right.
Now it doesn't matter what you want to store. There's a shape of data storage that's exactly built for that need. But now you've got to find it and learn it, and everybody's going to pick a different one. And you can't easily grab another developer off the shelf and say, hey, you know how to use database number 647, right? Like, no, they've never heard of it. Right?
Right.
It used to be that everybody knew relational, so you didn't have to start from scratch. So pros
That's a
and
good
cons
point.
to everything.
Yeah, that's a really good point. Frankly, you're right.
All right, so that's pushing us towards data fabric. And I, again, blast from the past. If you kind of look at the description, architectural design creates an integrated fabric of data and connected processes. So it used to be there's just the database, and then it was we need a data warehouse because that sounds cool. Big old warehouse of data, and IT can control it and lock the door and give certain people access to get into the warehouse. And we'll organize it the way we want it. Okay, this is going to be optimized for aggregated queries over time, for fast lookup to run our reports. And it's like, well, that's great. But eventually somebody said, what if I don't want to wait for all the DBAs to figure out the way they think it should be done? And I just want to get to it. Let's make a data lake. Let's put it in a nice, peaceful, placid lake. We'll row our boat around and we'll fish and we'll pull up some cool insights. And it's a data lake. Oh, great. And then I think everybody started just dumping their data in it, and it became a data swamp. It's just a dumping ground for whatever junk you want to put in. And it became pretty hard to figure all that out. No human was going to be able to handle that. So now I think we've got a new term because you have to rebrand every once in a while. Everything's got to have a new name, right? Application service provider to SOA to web app to SaaS. You got to rebrand occasionally. But now it's all right. So we're going to do the same kind of thing, but now we have this cool thing called AI and machine learning that we didn't used to have. That can try to figure out how to magically get us some value out of the pile of data we put in this lake or this fabric now. So you can see kind of Gardner's view on the right there. I think you've got the blue bars on top and yellow in the middle and the gray at the bottom. It's almost like if you abstract it, it's the data layer on the bottom, the business logic in the middle, and the user interface on top. That's basically what it is. User interface, how do I get my data out? Give me one view, give me access, give me APIs, give me streams, whatever I need to get the stuff out of the thing. And on the bottom layer, it's, well, how do I connect directly to all these databases, the NoSQL and the relational and the key value and all this other stuff? How do I connect to it and have a catalog that knows what's in it? And then the magic happens kind of in the middle with the AI figuring out, oh, well, user underscore ID is the same as user capital I, capital D is the same as username, right? Kind of do the magic mappings and coordination and let you have a sort of a more seamless, human-friendly user experience to get to all this data and get something out of it. At least that's my take. I know there's a lot of different ways to think about it. So what's driving adoption of this? More choice, the tyranny of choice, like we talked about. You've got hundreds of ways to store your data now, and you're putting more data in it than ever. I mean, we're talking about petabytes and petabytes now. It used to be terabyte was an astronomical number. Now people are talking exascale systems. So very complex when you try to integrate data at that scale, stored in vastly different ways with the different assumptions, gets expensive, gets complex. So if you have this fabric that gives you ideally a seamless interface that lets you query and report and get some insights across all of this, regardless of how it works under the covers, gives you a unified data environment. That's a huge advantage. So you can run analytics, reduce your cost, even reduce risk, reduce attack surface, depending on how it's stored, faster query. It boils down to business agility and flexibility, just like we heard with the microservices, just like we heard with hybrid cloud. I have to go faster. I can't wait for a year if I'm the business for the tech people to figure out how to get me the data I need. I don't want batch. I don't want to wait a week. I want it now. I want it real time. I want to talk to my computer and see how sales are doing instead of typing in some perfectly formatted, structured query that I don't understand. I just want the answer. Don't make me jump through the hoops to get it. I think this is what the business wants and why we're being pushed to do this, which makes a lot of sense. Lots of tech behind it. You mentioned the new stack, Eric. People can see some of these here, Kafka and Cassandra. Different ways to store things, different way to stream things, different way to interface is becoming the norm. There's going to be another one of these comes out all the time. It seems like it's almost impossible to keep on top of it, even though you think we would have had everything covered by now. It's still, there's a new one all the time.
Right, that's right. And there will be. I mean, part of the challenge here is future-proofing your architecture such that you can take advantage of what comes down the pike, right? I mean, that's one of the nice things about the microservices approach, but it's an architectural decision. And you've said it a few times now, if you engineer for something, if you understand which direction you want to go, you can solve a lot of these problems from the outset, as opposed to going quick and dirty just to get rolling and then just slowly calcifying a particular solution to where it's either going to break or it's just not going to be very efficient at all, right?
Yep. I think there's so many different approaches to this, but one approach that I like for a lot of things is if you don't know if something's going to succeed at scale, which hardly anybody does, it can work sometimes to start with something simple and grow. Okay, we can all draw the monolith on the board. Let's start with that. But if this thing starts to move and take off, instead of calcifying in place, like I said, and becomes this anchor that kills you, as you see the need to expand and grow and change and adapt to the business faster, use a strangler pattern or something like that and tease out your microservices and just add them where they're needed as they're needed, instead of going with the grandiose plan up front. I know some people disagree, and we can have great conversations about that. But whatever the plan is, expect it to evolve. Right. The only constant is change.
That's right.
You will be wrong. Whatever you think is going to happen next year won't. Something else will, and be ready to adapt. Whatever you do, don't think, oh, boy, got that architecture in place. Don't have to think about that for 20 more years. It's going to do great. Right? No way. Not going to happen. So be ready to spend more time on care and feeding of all the architecture and the components inside. It's not a one shot and you're done deal.
Yeah, that's really good advice too for the long term, for knowing what you can bite off. I mean, I can tell you, I learned about myself a long time ago. I tend to bite off a little bit more than I can chew, and I have to chew harder and get it done. But to take care of the care and feeding, you are going to need to pay attention to this, but not like it's not as bad as it used to be by any means, right? If you take the right approach, you can kind of solve a lot of these challenges. But you go down the wrong path too far. And if you haven't planned to enable agility, you're going to be hamstrung. And that's what it boils down to. And then you just can't change. And so things get more and more intense. I talk to consultants all the time. And one of my good friends said, "Oh, this new gig is good. It's not red yet. It's not code red. They brought me in before it was code red." That's good. That's what you want, because if it's code red, man, whoo, people are jumping off and, engineers quitting. That's not good.
Oh yeah, no, that gets ugly. Yeah, I think I think of, and we'll talk about this a little bit more too, but I think of the stuff on the page is open source, and I always, they say open source, open as in free as in speech, not free as in beer.
Right.
I've always said free as in puppy. If you adopt it, there's care and feeding.
That's
You're
a
going
good
to feed
one.
it, you're going to exercise it, you're going to take it to the vet. You have a lifetime commitment. And if you bite off a big project using any of the things we've talked about and think it's a one and done, and a business has a deadline of, okay, in 1 year we stop investing in this, move on to something else, bit rot will set in, it will decay, and somehow it will catch fire, fall over, and sink into the swamp. Right?
Yeah.
It just happens if you can't keep up with it. We're on the treadmill and we can't get off.
That's right. That's exactly right. Until you quit or die. So,
Yeah, quit or die.
look at the bright side.
Yeah, there's the bright side. Okay, so that brings us to data streaming. So another flavor, I think, of trying to go faster. So top left description, data streaming is the creation, ingestion, storage, and analysis of event stream data. And if you look at the growth, that's insane amount of growth. We're talking about a big market, 12.5 billion just US dollars, tripling, more than tripling within the next 4 years. That's just mind-boggling to think about how fast that's growing. We'll see some even faster growth numbers coming up. So huge. So what is this? Why is it happening? Well, we've got more real-time data than we've ever had before. Big data, IoT sensors are just spewing astronomical amounts of data. You think about all the connected cars now, the autonomous driving, the vehicles are, a lot of them are delivering many terabytes per day per car of metrics, other operational data being collected. That's an insane amount of data to digest, and that's coming in, streaming real time, one event at a time, one click of a UI, one temperature measurement of some sensor, one wind turbine measurement in a ball bearing, just massive amounts of data. Why? Because we can afford to do it now. The sensors are very cheap. Wi-Fi is cheap. Internet access is cheap. Bandwidth is getting cheap. So we can do it, and therefore we will do it. So now what do we do with the data? Do we process it in batch and you wait for a week for the answer? Nobody wants that. We now have the capability to give it to you real time. So everybody's got to have it real time. So kind of the benefits on the left, real-time processing. One bit of information, you stream it through your system. We'll talk about some of the ways to do that. And anybody who needs to look at that bit of data, that event, can do something about it. It's decoupled, completely decoupled, ideally, with all the great benefits of that. So you can get these real-time insights, better availability. You can replicate the streams, scale the streams, store them, aggregate them, get time series out of it, detect anomalies with AI. And I think that's the real key. We're going to see just an explosion. We've already been seeing an explosion of AI, but we're going to see an even bigger explosion, and that will continue to hockey stick up. You can see on the right, we kind of asked the question, or like Ben asked the question, what's basically happening in the next year with your real-time processing? And AI and machine learning was right at the top. Application monitoring, integration of different streams. So I think everybody's seeing that there's a huge potential there to say, now that we've got all this data, all these different 240 different kinds of sources, and we've got the data fabric, we've got it all over our different kinds of clouds coming in from everywhere, from every sensor at once. What do we do with it? Well, if we can funnel it into these streams and have AI join, merge, look for insights, look at anomalies, we can get massive amount of insight that we never could have gotten before, and that it's just frankly on a scale that humans can no longer comprehend. Right. We now have to have this stuff pre-digest our food for us and give us the answer, and then we can ask questions and try to figure out what's going on. But there's no way we can even probably count the number of sources, let alone correlate everything that's going on without the help of this other layer of processing.
Yeah, you bring up a lot of really interesting points here, and I know we want to get through a bit more of this, but I just wanted to throw out a quick analogy because we're not specifically talking about edge here, but it's sort of implied in a number of things that you've mentioned. And edge is such a fascinating concept, especially from the computational architecture, right?
Mhm.
Where do you do the compute now? Do you want to move all that edge data into a cloud data center somewhere? That's a whole heck of a lot of data movement. No, what you'd like to do is be able to process it at the edge and then just send upstream some little tidbits of information about, whether this is a high value customer or whether it's a serious incident or not a serious incident, things of that nature. But you can see how creative you can get, but you can also see how granular you can get to tackle the very specific problems and challenges that your business has. Because even across industries, even in oil and gas, which is a pretty well understood industry, nonetheless, your particular company is going to have a different DNA than any other company. Maybe what makes you special is some of the hardware that you figured out years ago. Maybe it's some process, for example. Maybe it's your personnel. Who knows? Your way of doing things is going to be different. And so all these options that you have about how and where to process the data, what to capture when, what to do with it all. I mean, it is that tyranny of choice, but it's good in that if you roll up your sleeves and think through this stuff, you can build tremendously powerful solutions that are going to give you a leg up on all of your competition, right, Rod?
Absolutely. Yeah, I think it's more tools in the toolbox than we've ever had before, which I think it can be really dangerous if you have not to pick on the young guys just because I'm getting old, I hope. But if you've only seen a few of these, you tend to still think of every problem as a nail and you've got a great new hammer. If you've been around the block a few times, you realize that, okay, every answer is it depends, and you got to think through the ramifications. We've got Amazon now putting AI in physical cameras that they're installing in manufacturing plants. So you're doing image recognition on camera and then feeding data and things, events upstream. You mentioned oil and gas. We've actually had one of our, at Perforce, one of our products, IMSL, has been running machine learning on the drill head down in the well in oil and gas for well over a decade to crunch and analyze massive amounts of data right at the point it's collected, because it's so much data you can't send it all somewhere. You've got to pre-crunch it, analyze it, and then kind of send a summary somewhere to be further analyzed. So yeah, more options than ever to collect data at the edge, do the compute where you need it, because chips are cheap. You can afford to do things like AI on a camera now, or almost anywhere, and have the bandwidth. So it's exciting and scary. Like I said, it's another layer to the tyranny of choice. It's another axis, which is exponential.
Well, what's really interesting here that's just kind of popping up in my mind here is that the cycle time on product design and deployment is a lot shorter than it used to be, even though it's still pretty long. You're still in years, if not, maybe months if you're really, really good with what you're doing. But the point you made about that one particular use case is very interesting, because if you think about when you're drilling down, I spent years in the oil and gas business learning from some pretty smart people. And it's a physical world. You have all these physical assets. You have all these different pieces of equipment that you have to use. And when you're drilling, well, first of all, you better gosh darn know that there's something down there before you invest all the money to put that thing up there and get it rolling, because it's incredibly expensive. And if it does not pay off, you're bumming. I mean, it's just a really painful. And look what just happened with the shale industry, right? With fracking, where the oil price got so low that all of a sudden it wasn't worth the effort. Then it shoots back up, and these guys have to figure out how to manage all that. But as you're drilling down, like you can do sonic, you can use sonar and all sorts of other things to kind of figure out what's underneath you and how long it's going to take to drill. But if you can gather data at the drill bit and understand what it's going through and how well it's working and run all the numbers on that stuff, again, that gets to be a game-changing advantage over your competition. If you have a service that's better in that one specific thing, all of a sudden you can get to the gold faster, and that's going to change the dynamic. So it's a really cool example you gave there, Rod, of how the sort of confluence of these technologies can open up new ways that dramatically change the landscape, throw all the prices out the window, and put you in the driver's seat.
I totally agree. And I think that's happening in every industry everywhere. I mean, analysts have been saying for a while, every one of the global 2000 companies is a software company. They're becoming fresh. Why? Because it's more flexible. You can go faster. You can innovate in ways like that with the logic in the processing on the drill head, and so many hundreds of other examples. I think everybody, if you haven't done this in your industry, take a step back and think about, what are we doing just because we've always done it this way? And what now, to your point, thanks to this confluence of all these new solutions that are available, can be brought to bear in a brand new way to disrupt the competition before we get disrupted by them or by a startup, and change the game. And it's amazingly exciting to me right now. I think user experiences kind of dominates all, and the user can be a developer, it can be a business. There's lots of ways to think about it. We all have access to these tools now. All the open source, all the stuff we're talking about today, it's practically free or actually free.
Right.
How are you going to use it better than the other guy? That's what it all comes down to. So
I mean,
you get to be creative.
Even the algorithms like TensorFlow and stuff like that. I mean, you can just go grab that stuff. I mean, what a fascinating dynamic that is, that you have these big guys offering that stuff for free. Well, why are they doing that for free? Because they want you to use their infrastructure to run the numbers. That's why they make the money when you put all your data in their cloud and leverage their compute to get that done. That's how they're getting paid, is on the storage and the compute. They just give you the algorithm to play with, which is, I mean, think about how wildly, just dramatically different that is from 10, 15 years ago. You can't, there's almost no comparison.
No, it's truly amazing. And you're getting state-of-the-art, cutting edge AI, machine learning, and other stuff for free. Last count I did in another presentation, future of software and things, over 9,000 different open source packages for AI alone. So everybody knows of the TensorFlow in the top 4 or 5. There's 9,000 of them. So no excuse. You have cloud. You have all the data stores we talked about. You've got AI. What are you going to do with it? That's what's cool. So what's next? What are we going to do with all this stuff? Well, I think, as we talked about, choice continues to grow. The blue line is kind of the growth of open source. The red line, kind of commercial, dropping. This is specifically around data, but I think it's in a lot of ways comparable in a number of different industries and aspects of tech. Commercial tends to focus on the relatively small number of proven technologies. There's a bunch of them out there, but relational being there in a bunch of others. But there are many, many hundreds, if not 1,000 plus, in the open source community. And so as you're seeing people move to microservices and now being able to pick and choose, well, for this one little service, I want a data store shaped like this. What's in open source? Oh, there is a thing. I'll use that. So we're seeing kind of a bigger distribution, a longer tail when it comes to usage of open source to kind of find best tool for the job. I think Graph is really kicking in. Neo4j is a graph database company. It's been around for a long time. The CEO just raised a massive round, and maybe this is self-serving data. I don't know where he got the numbers, but it's certainly believable that last year we spent $50 billion on database software. 4 years from now, it's going to be $100 billion. That's, again, mind-boggling numbers, that there's so many options. We're storing so much data in so many places with the microservices, with the hybrid cloud, with the data fabric and the data streaming, all the stuff we talked about. You've got more options. You're going to spend more money to take advantage of these new opportunities that weren't there. And I think another good example of that, if we did a survey, OpenLogic survey, and asked, which database technologies have used? And obviously there's not hundreds here. This is only the top, 25 or something, 20-ish. There's a lot in use already, even stuff, at the bottom of the list, Jackrabbit. Okay. I doubt anybody would have heard of Jackrabbit 10 years ago. So things are coming and going and changing all the time. MySQL's still at the top, and I think that includes probably MariaDB in those numbers. But the interesting bit is compare this to the next slide. So look at the bars now. This is what you're using now. And here's what you're planning to use in the next year. All the numbers went up, including Jackrabbit, including everything, right? So people are saying, Yeah, we are adopting all the things we've talked about in this webinar, and we're growing across the board. We're not standardizing on one thing. We're using more of all of it because it depends on the job. It's
Right.
no longer one size fits all. We've got choice and we're going to take advantage of it, which I think is
That's right.
pretty exciting.
It's amazing. I mean, it really is amazing. And, we have a good question from an audience member who's asking, who is the biggest data fabric platform? Who is providing that platform? That's a very, very compelling question because from my perspective, there's no answer to it. I mean, there is a data fabric magic quadrant that you can go to Gardner and get. And last time I looked, Talon was at the top, which I thought was kind of interesting. They're an integration vendor, obviously Java based, open source. They've been open source for years. They're one of the first ones to get out there on the data integration space. But there's really no winner in terms of data fabric that I've seen. And so it becomes an architectural project for your company to figure out how you're going to accomplish that. Isn't that right, Ron?
Yeah, I think it's going to be another one of those evolving spaces. There'll probably be a winner on top that will change and leapfrog from time to time as somebody introduces a new AI or a new way to put APIs or a new way to deal with the fabric, or we've introduced time series in a better way. I think it depends on the aspect. When you think of data fabric in your industry or your company, what does it mean to you? What do you need? That's going to drive probably a different vendor, a different solution over time. This is not nailed down yet. This is like microservices is going to continue to evolve and change a lot over the next few years, just like it has over the last few. I can't even predict when there'll be a stable set of quote winners in that area yet. It's just a very interesting, fast-moving, evolving part of technology.
Yeah, that's
which
a good
it's
question.
fun but frustrating.
Yeah, right. Another really good question came across. I've got several good questions here from an audience member who writes, how do you compare Snowflake's success to the open source vision as being discussed? It's an interesting question. So if you look at the success of Snowflake, lots of factors go in that. I was talking about this earlier today, in fact, that what Snowflake did that was very clever was separating compute and storage, but they also figured out that what you want to be able to do is spin up a data warehouse very quickly. And I kind of alluded to these declarative data pipelines as a company called Data Ops Live that came up with a fantastic concept where they create a declarative data pipeline for Snowflake. And so basically you'd make your changes in the pipeline and then just project that onto the screen, which is Snowflake, right? So Snowflake is huge, but if you look at look at this, what we have, are you planning on using these technologies in the next 12 months? You got MySQL to top PostgreSQL. You've got MongoDB up there, Redis, Elasticsearch, Hadoop, MariaDB. I mean, already you've got all these big ones. I don't even see Snowflake in there. Maybe it wasn't on the list, but this market is just breathtakingly huge. So I think Snowflake is sort of the poster child for data warehousing is still very real. It's still very powerful. We only kind of scratched the surface on it in the sort of on-prem days. And now it's up in the cloud. It's incredibly powerful, but it's good for data warehousing type use cases, right? And a data fabric has to be good for all kinds of different data use cases. I think it's the biggest difference, right, Ron?
Yeah. Yeah, I think if you think the numbers are correct, and we're going to say we're going to spend $100 billion 4 years from now on data stuff, this list could probably include another 100 products, and the one at the very bottom still has significant usage.
Right.
Right? So it's just a huge long tail, and things like Snowflake, which great name by the way with the data warehouse, right? Kind of
Right.
standard pattern
I think
for getting data.
they were thinking about that.
Yeah. Makes a lot of sense, right? Because there's still, although we're looking at all these things, look at the top. Top three are relational databases. So obviously still alive and kicking in practically every legacy app in the world. Clearly, an incumbent there. So still a lot of use, and a lot of things still fit that paradigm. So most of these things here, I think, are newer, relatively speaking, and they're probably going to be used for newer things like new microservices, new apps, startups, new innovative areas of a business, et cetera. So it's going to take a long time before they're as mature as the data warehouse, as the Snowflakes of the world. And so we're going to have to live in a world where there's this mix, this dichotomy. And I think that's where, the AI, the data fabric, the technologies that try to make it easier to access across all of these things and give standardized, normalized views are going to be even more and more important over time as we continue to explode in this long tail, but have the not anchor in a bad way, but anchor in a good way, kind of the core, the heart of the enterprise being those relational databases. They need to all play nicely together.
Yep, that's right. We had one really good question that came from an audience member. And folks, if we don't get to all these, I'll be sure to pass them on to Team Perforce over there. But one attendee is asking, what can all these technologies do to come together to work with census data? And that's a fantastic use case, because with census data, you have all these different characteristics that you're trying to understand. Let's say you're trying to do urban planning, for example, or just kind of understand what the economics will be for different geographies as people are moving around, et cetera. And the sort of short answer is you can do all kinds of things with that data. I mean, again, there's this remarkable choice of options of what you can do, but really what you want to be doing is slicing and dicing and doing scenario analysis, right, Rod?
Yeah, I think in the interest of time, we probably better get through the last conclusion real quick. But
yeah, go ahead.
I think there's so many ways you can do that, because we've got in this list, you can see a lot of options for structured data, unstructured data, textual data, pure search. There's so many options. I think that's what it comes to, having so many tools in the bag now, which is really interesting. But let me try to get through the last few slides real quick before we wrap up. So you can kind of see graph database, I think, really kind of exploding as we find, like in the social media world, the Facebooks, the Twitters, we find a lot of data is connected via graphs. I know you, you know somebody else, etc., and lots of things like that. Also, time series kind of bubbling up. And at the bottom in red is a relational database, fairly flat, but not going down, which means everything essentially, we're just adding data and getting access in new ways. None of it's going away. So quick final thoughts. I think what this all boils down to me, all things we talked about today, from microservices, hybrid cloud, data fabric, data streaming, all the tools, we have more flexibility than ever to go faster and pick the best tool for the job. Pick the one that fits. All these have in common decoupling, downsizing, dynamic integration, smaller parts, moving faster, independently, loosely coupled, all come with challenges, but you get to go faster. And data and analytics will be central to all areas of enterprise business going forward. The business wants real-time access to what are customers doing right now. We just showed an ad on Facebook. It's been 35 seconds. Why are you telling me what happened yet? We want instant gratification. We want instant answers, and we want to be able to tweak and change what we do on the fly, autonomously even. And that's all driven by AI. It's going to fundamentally change, I think, how we approach data. This isn't quite here yet. It's in the works, and it's going to be really interesting to keep an eye on. But no matter what you do, I think demonstrate ROI. You can have a fun time playing with all these technologies. As a technologist, I would love to do nothing but play with this stuff. But it really comes down to, what are we getting out of it? What's the short-term gain? How does it fit into our long-term vision? Does this help with agility down the road? Will this thing be around 5 to 10 years? We mentioned earlier how fast apps can be developed. Some of the recent analysis has shown that it takes about 9 months to build a new modern web app launched in an enterprise with all the new technologies we have. But if it's successful, it can be maintained in production for up to 20 years. Wow. So think about the discrepancy. The developers have moved on after a year. They're on a new tech stack. 10 years from now, who even knows what the name of the project is that they used to build that web app? Somebody's left holding the bag for support for a long time. So that's another challenge I think we have as an industry, trying to go so fast, but keep things up and running for a long time. And that kind of ends with our pitch on OpenLogic. We do have open source technical support for over 400 packages. So a lot of things we talked about today. We've been doing this for the last 15 years with guaranteed SLAs for some of the biggest enterprises in the world. So we can help with keeping this stuff up and running after developers are moved on, but also with guidance. What package should I use? Helping with that tyranny of choice and those kind of things. We do have a couple of guides that people can download based on Forrester analysis and Gardner and things we've done with Floor Group. We mentioned the new stack with Cassandra, Kafka, and Spark. I think that's a great one, as well as a guide on trying to help people decide which open source database or data store should they pick.
Yeah. Well, and just as a closing comment here, folks, and we've got a lot of great questions. I'm going to pass these all on to Rod and his team to get back to you. But I think one of the key closing point here is that these 4 trends we're talking about are not isolated, and they should not be viewed in isolation, right? The key is to view them all through the lens of what is possible today. And you can quickly understand how streaming comes into play, for example, why microservices really is the de facto winner. I mean, I think Kubernetes is the de facto operating system for the cloud. I don't really see that changing anytime soon. We did have some recent hubbub in the CentOS space that I know you guys have talked about a little bit. But that foundation is so important. I mean, I believe that really Linux took off because Microsoft kept pulling the rug out from underneath people year after year with different operating systems. You had to go recompile the code, and did they change something? It was very, very difficult. But the point is that the new stack really is tremendously powerful, so much more powerful than anything in the past. And you got to bite off what you can chew for whatever's most important for your business. Focus on low-hanging fruit, or focus on what really needs to be updated. Is it customer service? Is it supply chain? Is it analytics? Whatever it is, figure that out and focus on that first. Get that done and tackled, and then move on to the next thing. Closing thoughts, Rod?
I think that's a good summary. Kind of think about it. Now that you have all these new tools in the bag, what are your most pressing challenges? And how do you attack them maybe in a new way, a way you wouldn't have been able to tackle it just 5 years ago because you got new options,
right?
Kind of a new perspective on things. Change the game, win against the competition with a new way of thinking about it.
Yeah, that's right. Well, and Rod's point is very well taken, that there are so many new ways of doing things. You need to just get back, get out the whiteboard, look at the process that you have, and recognize that there are many of these cycle times that can be collapsed from hours to minutes, even to seconds, even with a serverless architecture, instantaneous. But figure out what is the most important. Where is the friction? Where are people unhappy in your organization? Who's the unhappiest person and why? And dig into that, and you're probably going to find where you should focus your attention, right?
Yeah. Think about user experience. I think that'd be my final word on almost anything technology. Where is there pain? How do you take it away?
That's it. Well, folks, we do archive all these webinars, so feel free to share it with your colleagues. It'll go up. It'll stay in Zoom, and we'll also put a link to it on insideanalysis.com. Look these folks up. Perforce, OpenLogic, very cool. They've been doing it for 15 years. They can help you understand the new stack and move forward. And with that, we'll bid you farewell, folks. Thanks for your time and attention and all these great questions. We'll talk to you next time, folks. Bye-bye.
Thank you.